Alright, so we are starting on lesson 324. Okay, this is pretty much your last lesson before you are going to have a test on this. Um, most of you, I feel like, I'm not going to say I feel like, I'm going to say most of you should um, be pretty comfortable with this stuff. Probably going to give you a day to practice and do lesson 325 in the closure section. Probably just essentially give you a bunch of worksheets to do to practice before we have a test on probably Wednesday or Thursday. But this lesson is all about adding, subtraction, radical expressions, basically adding, subtraction, fractions. Now, you should know that to add or subtract a fraction, so to add or subtract fraction, what do you have to have? Okay, if you're going to say 1/2 plus 3/6, can you add those just like that? So that equals 4/8. No, it doesn't. It actually equals 1. But how do we get that? We've got to get common denominators, okay? So 1/2 plus 3/6, find our least common denominator, 6. So this times 3, if I do it to the bottom, I gotta do it to the top. There's your giant 1 that we kind of talked about. Those would eliminate each other. So now you got 3/6 plus 3/6. Your denominator stays the same, and you wind up with 6/6 or 1. Okay. Same thing if you're subtracting. You've got to get a common denominator. The denominator stays the same, and you add or you subtract the numerator. Okay, and then you have to simplify. Always have to simplify. All right, that's just a real quick and easy one. I'm gonna switch colored pens because looking at my computer screen, it doesn't look. I just don't like the way that pen writes for this lesson. It's not very easy to see. Alright, so we're going to start with problem 397. It says, with your team, read the directions for Monica's sister for homework from 392. Verify that everyone obtained the same answer and prepared to show how you added the fractions to the class. So 1/3 plus 2/5. 1/3 plus 2/5. Okay, so how did we add those? Again, if you would have said 3/8, that is not right. Okay, what you should have said is, what's my least common denominator? Okay, it's going to be 15. 3 times 5, 1 times 5, so 5/15 times 3 times 3, 6/15. Now I have 11/15. Okay, if you didn't get that, you need to stop right now, and you need to understand that. Get somebody around you, get another teacher. Somebody needs to get that explained to you so that you understand it. If not, this is going to be a hard test for you, a hard lesson for you. All right. A says, now Monica's sister wants to know why. Why does she have to do all those steps with the common denominator? Okay. The truth is, there's not a lot of steps. You're in Algebra 2 at this point. You should be able to look at that and see what the common denominator is. Now the other thing, you can always find a common denominator by multiplying the denominator of the first term by the denominator of the second term. That's going to give you your common denominator. That's going to be something to remember that's going to be important when you're doing these longer problems like problem 398. Okay. All right. Why is a fraction, or what is a fraction anyway, and why does adding them have to be so complicated? Fraction is just a percentage of a number. It's a way you write a number smaller than 1. All right, draw some pictures or diagrams to make up the situation that would help her to know what fractions like 1/3 and 2/5 mean. If it was me, this would be mine. I would think pizza. You've got a whole pizza plus a whole pizza. Okay. And now we take somebody like Jason, who's only going to leave a third of the pizza. So all he's going to leave after he gets through eating is a third of the pizza. Okay. And then you got somebody like Tiffany, who's going to, let's say, divide the pizza into fifths. So you got 1, 2, 3, 4, 5 slices. That should be even slices. Tiffany's going to eat only 2 of the slices before the volleyball game. Okay. So this is a third is left. This is 2/5 is gone. Okay. I know that's kind of a messed up way of thinking about it, but you could also say Jason eats 1 of 3 pieces, Tiffany eats 2 of 5. So how much of a total pizza did they eat? Well, this was sausage and this was pepperoni. Well, then how much of a total pizza did they eat? Well, it's hard to add these because they're different size slices. So what we want to do is, what if we can make this into 15 slices, so to speak? Okay, so this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 slices, however how you want to draw it. And this is, you're going to do the same thing and make 15 slices, okay? But the bottom line is this becomes, you multiply this times 5, this times 3. If you do it to the bottom, you have to do it to the top. Now we've already added it up here. We know they ate 11 out of 15 slices of a whole pizza. Okay? That's the easiest way I can kind of explain it. So did they eat a whole pizza? No. Did they eat more than half of it? Yes. Now, did they eat more than 2/3 of it? How would you be able to look at that? Well, you would reduce this to a, how can you reduce 15 to 3? You divide by 5. You divide by 5. Okay, we want to know they ate more than 2/3. Was 11 divided by 5 greater than 2? We know it's 2 point something something something. Okay, so did they together eat more than 2/3 of the pizza? Yes, they did, because they ate 2 point something 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 over 3. Okay, did they eat more than 3/4 of the pizza? Well, what's 3/4 of 15? So 11 is to 15, or blank is to 15, question mark is to 15, as what is to 3/4. Now, how would you solve that? You would say 4x equals 45. I got 45 by saying 15 times 3 divided by 4. So x equals 4 divided by 45. 1. So that's going to be some more. So 3/4 of the pizza would have been 11.2 slices. So they didn't quite eat 3/4 of the pizza. They ate less than 3/4 because 11 is less than 3/4, or 11 is less than 11.2. It's just a way that you can compare things and be able to answer that. All right. Again, you couldn't have done any of that really without knowing that you had to have a common denominator so that you can compare them. The other thing that I like to kind of always do is think about it this way. If you had a stack of $1 bills and a stack of $100 bills, and they put a blindfold on you, which stack would you take? A stack that was 10 bills high or a stack that was 5 bills high? Okay. Well, you would, the only thing that you know is that it's all dollar bills and $100 bills are the same size, you would probably take the one that's 10 high. Well, you're going to miss out on, that's going to be $10 compared to $500. Unless you can get them in the same thing, a common denominator, something that you can count the same by, then you're not going to know which one is more valuable. You've got to have common denominators to compare them, to add them, and subtract them. All right, 398. Extend the procedures your class developed for numerical fractions to add these algebraic fractions. Okay, so they give you in problem 398, they say 2 over x minus 1, you're right there, 2 over x minus 1 plus 3 over x plus 5. Now, we just said they got to have common denominators to add and subtract. How did we say we could always find a common denominator? You can always find it by multiplying the denominators by each other. Okay, and if you do it to the bottom, you have to do it to the top. Okay, so I'm going to rewrite this as 2 times something plus 3 times something over x minus 1 times something over x plus 5 times something. Now these boxes, this and this are going to be the same, this and this are going to be the same. They're the opposite denominator, x plus 5. Okay, so x plus 5, x minus 1, x minus 1. Now they have common denominators. Okay, so now I can say this becomes 2x plus 5 plus 3x minus 1. Okay, this is over x minus 1, x plus 5. This is over x minus 1, x plus 5. Because of the commutative property, I can kind of move these around. Now, add your like terms. Alright, so take a second, add your like terms. Shouldn't be very hard for you. Shouldn't have to guess a whole lot or anything like that. Alright, now what did you wind up getting? Also, did you see anywhere where I made a mistake? Okay. Alright, first off, here's one right here. This should have been 2x plus 10, 3x minus 3. Okay. Now, to be able to do that, what you would think you would wind up with is 5x plus 7 over x minus 1, x plus 5. Okay, that is not your answer. Hate to tell you, it's just not. Okay, that would be too simple for Algebra 2. So what you're going to have to do is you're going to have to take this and you're going to have to figure out, going back to our 397, what did we do? Where did we do something different? Take a second to talk about it. Pause the video if you need to. I'm going to try to find a an easy problem kind of example that's easier than that to look at. All right, looking at this, to me, I'm going to go back and we're going to look at a little bit different problem that actually looks harder, but I think is easier. Then we're going to come back to this. Okay, I'm going to give you a problem that is 2x minus 1 over 4x minus 1 plus x minus 2 over x plus 3. Now, right off the bat, you can see they're not common denominators, okay? So we're going to multiply each of these by the opposite denominator. Okay, so we're going to multiply this by x plus 3. We'll multiply this by 4x minus 1. Okay, now, how are you going to do that? FOIL it, first, outer, inner, last. Okay, so first, 2x times x is 2x squared. Outer, 2x times 3, so plus 6x. Inner, negative 1x. And last, negative 1 times 3 is negative 3. Plus, first, that's going to be 4x squared. Outer, that's going to be negative 1x. Inner, negative 8x. And last, it's going to be plus 2. Okay, all over first. It's going to be what? 4x squared. Outer plus 12x. Inner minus 1x. And last plus 12. Okay, so combine all your like terms. All right, 2x, so I got 6x squared. So I use that, and I use that. Okay, that's going to be 5x. Subtract another one, that's 4x. Subtract another one, or subtract 8 from 4, so that's negative 4x. So I've used that. Now what's negative 3 minus 2 minus 1? All of this is going to be over. You can write it out like this, or most of the time they leave it just like this, 4x minus 1 times x plus 3. A lot of times they just leave it just like that. To me, even though it looks harder from the get-go, it actually winds up being easier than this one up here was. I don't know why. To me it is. It just is. The answer to this one, this equals 2x squared plus 13x minus 3 all over x minus 1, x plus 5. Okay. So here down, from here to here, we did all that wrong, okay? It's kind of funny when you look at it because you don't really think of it that way. But essentially what you're saying is distribute this to this, 2x plus 10, then distribute this to this, 3x minus 3. Now multiply those. You wind up with, that's still not right. Multiply this times this. 2 times 3. Okay, that's going to give you, I messed up completely on that. Let me go back and start over on that. Alright, 398. Alright. You've got 2x, and that's where I messed up from the get-go, is I didn't write the problem right. Okay, 2x minus 1 plus 3 over x plus 5. And just so we can go back and look and show you, you can see right here, I wrote the problem down wrong. If you write it down wrong, you're probably going to miss it. Alright, now it becomes a lot easier. Where did this come from? It came from here. Okay, so it's got to be here too. Now, if you remember that second problem that I did I do anything to the denominator? No, I could have just left it just like this. Now, if you notice, I didn't write the x plus 5 because I want these to be in the same order. But what needs to go in this blank? The x minus 1. Okay. Now, if I do this out, I'm going to get 2x times x is 2x squared. 2x times 5 is plus 10x plus 3x minus 3. So I wind up with 2x squared plus 13x minus 3 over, I'm just going to leave this the same, x minus 1, x plus 5, make sure I put my parentheses around it, and that is in fact your correct answer. Okay, so don't be like me, make sure you write the problem down right. Alright, 399. Alright, if you got any questions, stop the video, pause it, kind of go over it, okay? Doesn't really get any harder than that, but it doesn't get any easier either, so you've got to be able to do it. Alright, 399a. Okay, it says now that fractions below after you add them, be sure to check to see the numerator can be factored. You may be able to get a simpler answer, okay? So that should tip you off. If you're taking the ACT or something and it says make sure it's factored, then that should tell you, hey, I probably am going to have to factor this. Alright, so we're going to say 399a, we've got x over 3x plus 1 plus 2x squared minus 2 over x minus 5 times 3x plus 1. Alright, now, what do you have to do to each side, or maybe not even to each side, but to one side, to make them have common denominators? Notice you already have those in common, so you need this where? You need it over here. It's going to be over x minus 5, 3x plus 1. Now, why did I write this first? Because I want it to be in the same order as this. Okay, plus x minus 5, 3x plus 1. And up here on the top, I already got 2x squared minus 2. Alright, so in fact, multiply this. X squared minus 5x plus 2x squared minus 2. This is going to be over x minus 5, 3x plus 1. Leave that like it is. Combine your like terms. Okay, you got an x squared and an x squared. So 1x squared plus 2x squared is 3x squared minus 5x minus 2. over x minus 5, 3x plus 1. Alright, remember the part of the instruction said, see if your numerator can be factored. Can it be factored? Okay, so is there anything that you can factor out? Well, can I snowflake this? Okay, so look and see if I can snowflake it. Okay, I can snowflake it. A times c is negative 6. I need this to be negative 5. I need the factors of negative 6. So 1 and 6, 2 and 3. I need this to be negative. I need the 5 to be negative. Okay. Does that make sense? Okay. So I can factor, or I can simplify that a little bit, and then see if you can pull anything out. Can you? Let's see. If you're looking at this, make sure I did all this right. -2, that came from there. -3. No, -5, that's right. Alright, so that right there is, you would wind up with x there and x there, -6, +1. So you wind up with x plus 1 times x minus 6 over what? Or I'm sorry, this would be, you got to put this 3. You got to put, if there's anything in front of that a, you got to put it there. So this becomes 3, this becomes 3x plus 1. That was a problem that if you remember, Miss Terry came in and did that problem on the board. That was the problem. That's where we kind of messed up. Now you can reduce this. Now, just hold tight for a second. Or you can go ahead and do it. What does that reduce to? That reduces to, divide each by 3. That reduces to x minus 2. So now I should have, scratch this, 3x plus 1 from right here times x minus 2 from where I reduced this over x minus 5 and 3x plus 1. Lo and behold, we've got a giant 1, x minus 2, x minus 5. And x cannot equal what? It cannot equal 5. Okay. This step right here is what messed me up on the previous lesson. Okay. I didn't put this, whatever's in front of this a has to go in front of this, and then you can reduce it. Okay. All right. Let's look at b. All right. So b is 9 minus 3x over x plus 3, x minus 3, plus 2 over x plus 3. Alright, so what's missing? This x minus 3 is missing from over here. Okay, it's not hard to see. Maybe harder to do than it is to see a lot of the times. Alright, so this one just moves down, plus 2 times x minus 3. Now I have like denominators, common denominators, whatever you want to call it. Okay, so now I've got 9 minus 3x plus 2 times x is 2x, 2 times negative 3 is negative 6. all of this over. Now, if you notice, I kind of took out a step right there. I didn't rewrite both of these twice. I just put them over that. Now, I'm going to combine my like terms. 9 minus 6 is 3. I'm going to move it to the back side. Okay. Negative 3 minus 2, negative x plus 3. Okay. Over x plus 3, x minus 3. Now, do you have any common denominators? Or do you have any, or greatest common factor, anything like that? Is there anything that you can pull out, essentially? Let's see, let's make sure I got all this stuff right. And once again, I didn't copy it right. This should have been a 2x. So how does that change everything? This becomes 2x squared minus 6x. I'm really screwing everything up tonight. So this becomes now 2x squared minus 9x plus 9. So let's rewrite it down here so it's easier to see. 2x squared minus 9x plus 9 over x plus 3, x minus 3. Now, this is something I'm going to kind of tell you on. This is my second time today to do this lesson because I worked it once through just to make sure I knew how to do it all. And you've seen me make 2 mistakes because I kind of rushed through it. Take your time doing the problems, okay, so that you know that you get them right. Now I'm going to snowflake this, okay, because I think I can pull something out. So snowflake it. Now I'm going to go ahead and, the mistake that I've been making is I've just been putting an x here. Okay, I'm going to go ahead and put my 2, which again comes from right here. Alright, 2 times 9 is 18, negative 9. So I need 2 numbers that multiply to be 18, add together to be 9. Real quick, 6 and 3. Okay, both of them need to be negative because they need to add to be negative 9. Negative 3 times negative 6 is positive 18. So negative 3, negative 6. So now I have 2x minus 3. Can I reduce this? Yes, I can divide each by 2. So 2 times 2 divided by 2 is 1. Negative 6 divided by 2 is negative 3. All this over x plus 3, x minus 3. Those can cancel out because they are the same. Your answer is 2x minus 3 over x plus 3. Now again, the mistake that you're going to make the most often is not math or anything like that related. It's getting into too big of a hurry, just like I've done. Alright. And if you want to believe that I made that mistake on purpose, go ahead and believe it, but it wasn't. Alright. 3-100. It gives you an expression. The expression it gives you is 2x minus 1 over 3x squared plus 13x plus 4 plus x plus 3 over x squared minus 3x minus 28. Okay, this is the last problem. This is 3-100. Okay, this is the last problem. So part A says, with your team, decide how you can alter the expression so that the fractions have a common denominator. Be ready to share your ideas with the class. So talk about that for a second. Really kind of come up with some different ways, okay? See if you can't find a way, find something. pause it if you need some more time to talk about it. Alright, but we're going to look at it. Alright, this is what I would do. First thing I would do is I would snowflake that. So I'm going to put a 3x, 3x. Alright, a times c is 12, 13, that's an easy one, 12 and 1, or 1 and 12, okay? Alright, so now I've got the denominator here is 3x plus 1 times, I can reduce this, divide each by 3, x plus 4. Okay, now I'm going to snowflake this side. Do I need to put anything in front of the x? No, because there's a 1 there. So I got negative 28. It needs to be negative 3. I'm tired. I can't think of the factors of negative 28. So I'm going to write 28, 1 and 28, 2 and 14, 4 and 12. Is that right? No. 4 and 6 is 24. 4 and 7. 4 and 7 is 28. Now right there, I see a difference of 3. I know this has to be negative. I know this has to be negative, okay? So I know one of these numbers has to be negative. Because this is negative, I know that the biggest number has to be negative. Okay? Negative 7 plus 4 is negative 3. So 4, negative 7. Alright, so on this side, I kind of went down further than I should have. But I've got x plus 4, x minus 7. Now, do you think there's a reason why I wrote it that way? Yes. You've got a common you already have one thing in common. Now, from the get-go, you could have said this times this and this times this to the top and bottom, and you would have been okay to do it that way. It would have been a lot longer and a lot harder, but you could have done that. If you're doing it this way, now what do you need to multiply this side by? All you need to do is say times, we're going to put it over here on the front because it's already on the front, x minus 7. Okay, and this side needs to be multiplied by 3x plus 1. Okay, so now, first, outer, inner, last. Do you see what I've done? Okay, I'm going to leave my denominator the same. Okay, and I'm going to say 2x, that's going to be 2x squared, outer minus 1x, inner minus 14x, last plus 7. So that becomes 2x squared minus 15x plus 7. And over here, I've got 3x squared, outer plus x, inner plus 9x, last plus 3, combine my like terms, 3x squared plus 10x plus 3. Make sense so far? Alright, let's go back and look at, I just want to look at the steps that I did on this problem right here. Okay, when I got to here, I've done all my multiplying. I just combined my like terms. Okay, so on here, I'm going to combine my like terms. So I have wind up with 5x squared minus 5x plus 10. All of this is over what? X minus 7, 3x plus 1, x plus 4. Now, do you have anything that you can pull out of that? You should see those multiples of 5. So let's pull out those multiples of 5. Okay, x squared minus 5x plus 2. All of that is over x minus 7, 3x plus 1, x plus 4. Now, what I need to do to this, I need to Christmas tree it. So I want to, not Christmas tree it, snowflake it. Okay. So I have an x and an x. I have 2. And I have a negative 5. Okay, can I snowflake that? That's the question, is can I snowflake it? What are the multiples of 2? 1 and 2. There's no way you can make it equal negative 5. Okay, so right there, I'm kind of pretty much done with it to a sense. Now, what you can do if you want to kind of work backwards, or let's finish talking about A before we get down any further. All right, A says, what did you need to do? Well, you needed to multiply the left by the x minus 7 and the right by 3x plus 1, okay? B, if you don't add the fractions, then simplify the results if possible. I'm going to snowflake, I pulled out that, okay? I'm going to snowflake this as well, okay? So now I'm going to have 5x and 5x. Okay, this is kind of the beauty of snowflaking. If you forget to pull out that greatest common factor, a lot of times it'll actually save you. So let's ignore this for a second. Alright, so I need the multiples of 50. I need it to be negative 5. That's pretty easy, 5 and 10. Okay. Make sense? That shouldn't have been very hard for you to see. The hardest part for you to see, which some of you have probably already caught on, this somewhere I have messed up. Should have been 5x squared. The book is saying this should have been 5x squared plus 5x plus 10. I tend to disagree with that. I'm going to go up here and I'm just going to check my work. 2x squared. Alright, now outer negative 1, inner negative 14. Okay, so I know that's right. Last is positive 7. Now here, 3x squared, outer is plus 1, inner is 9x, last is 3. So I know that's right. I'm not real sure how make sure I copy the problem down wrong, because I do have a tendency of doing that. 2x minus 1. Alright, without a doubt, the book is wrong on this one, okay? Or at least the answer section, because it should be this right here. I'm just going to do it the way that the book had it set up. They wanted this to be negative 10 and this to be a positive 15 to make this positive, okay? And if that's the case, that changes this, I believe. Yeah, that's going to change some stuff. Alright, so that's going to change this to a now if you pull that out, snowflake it, you've got, this becomes a 5. I'm saying it does, it may not. Alright, let's go back to this one. Alright, so that's going to be 50. This is going to be 5x, 5x. This is going to be 5. Alright, I need the factors of 50. 1 and 50. 2 and 25. 3 and nothing, 4 and nothing, 5 and 10. 6, 7, 8, 9, nothing. Okay, now I need this to be I need it to be 5. So again, they made another mistake. Again, I'm not crazy because I've looked at it about 10 times now. What they eventually wanted you to get to is this should be a negative 5 and this should be a positive 50. Which is what it was, I guess. But anyway, so this is going to have to be negative, positive. So now you wind up with 5 here, negative 10 here. Is that correct? Yeah. Somewhere along the lines, they have completely messed up in the book. Because I know that I'm doing it right. So I've checked it about 10 times now. Alright, so x plus 1 times x minus 2. Because I can reduce that and I can reduce that over x minus 7, 3x plus 1, x plus 4. Alright, and that's it. I mean, that's, there isn't anything that you can pull out of there. There's nothing you can reduce, any of that stuff. So you could have left your answer as this, or you could have reduced it to here. Now, again, I'm not real sure. Somewhere in the book, and y'all may be able to find the mistake, and I just may not be seeing it right. But they wanted both of these to be positive. Okay, if that would have been the case, they needed to make that positive and that positive. But I know the Algebra 1 book had a bunch of mistakes like that in it. All right, last problem we're going to do, and y'all are done. Start reviewing for your test is C. All right, C says repeat the process to subtract the expression below. Okay, so 3-100, problem C is 2 over x plus 4 minus 4x minus x squared over x squared minus 16. Alright, right now, right off the bat, you should have saw this and saw a difference of squares. So you shouldn't have to do anything to that, except for no. You should be able to break that down right now in your head and say, x plus 4 and x minus 4. Okay, see that? So now you know that this has to be multiplied by something, and that something is a minus 4, x minus 4. Okay, again, you should have seen that right off the bat and thought difference of squares. That's going to make it a whole lot easier. Now remember, this is minus, okay? So your denominator is still going to be that x plus 4, then the x minus 4, okay? Multiply that out, 2x minus 8, okay? Put that in parentheses. It's going to be important to put that in parentheses. Put this in parentheses. Now, some of you will do this one way, some of you will do another way. The easiest way I know is to distribute this negative sign. So this becomes 2x minus 8 minus 4x, okay, distribute the negative sign, plus x squared. Okay, I distributed the negative sign. So now this becomes x squared minus 2x minus 8 over x plus 4, x minus 4, and we know we have to do what to the numerator? We have to snowflake it. Alright, so to snowflake it, snowflaking it, we are going to have to say a times c is negative 8, negative 2. That shouldn't be too hard. 4 and 2. This needs to be negative, this needs to be positive, so x plus 2, x minus 4, x plus 4, x minus 4, your giant 1. Your answer winds up being x plus 2, x plus 4. Okay? Alright, so now, pretty much through this lesson, what you need to remember, one is take your time and do it. Make sure you write it the correct way. On this particular problem, probably a good lesson through this whole problem right here is don't let, if you're sure about it, like I knew that I did this right. I went through it back and checked it. We checked it 2 or 3 times in class. I knew that I did it right. There wasn't any doubt that I did it right. I had to change it a little bit to kind of match the answer from the book. But the answer in the book is wrong. I'll do it. I'll bet you $100. Probably not, because you may find out where I made a mistake. But the answer in the book is wrong. And so I knew it was right. Trust yourself to know it's right if you've checked it a couple times. But besides that, y'all get ready for your test. Have a good day. And I'll have you another lesson tomorrow.